everyone, I am A. Nirisha, Assistant Professor in the Department of CSIT from MLR Institution of Technology. Today we are going to discuss about operators in C, the remaining part. So as we discussed about the operators, it is nothing but a symbol that we are going to perform some kind of operations. So the types of operators are arithmetic operators, relational operators, logical operators, and increment and decrement operators. So these are all the 4 operators that we have discussed in the previous class. So now we are going to discuss about assignment operators, bitwise operators, and conditional operators. So coming to the bitwise operator, the bitwise operators will perform on the bit levels. So the bitwise operators will perform on the bit level operations in the C programming language. So when we use the bitwise operations, the operations are performed based on the binary values. The following operators describes about the bitwise operators. So here the bitwise operators are bitwise AND, bitwise OR, bitwise XOR, and a left shift operator and right shift operator. So these are going to perform only on the bit levels. Only on the bit levels. Here the bit levels are 0 and 1. Coming to the bitwise AND. So it is also same as logical AND operator. But there in the logical AND operator, we are performing the operations on the multiple conditions. In the bitwise operator, we are performing the operations only on the bit levels. So the output coming to the bitwise AND, the output of bitwise AND is 1 if all the corresponding bit of 2 operands is 1. And in the bitwise OR operator, the output is 1 if at least one corresponding bit of 2 operands is 1. And bitwise XOR operator, the output is 1 if corresponding 2-bit operands are opposite, and it is denoted by this symbol. This is the symbol that we are using for bitwise XOR. And left shift operators are the operators that we are using is 2 less than symbols and 2 greater than symbols. Here the left shift operators shifts all bits towards the left by certain number of specified bits. And coming to the right shift operators, the all bits will be shift towards the right by certain number of the specified bits. So many bits you have specified, so that many bits that are moved towards its rightwise if you are using the right shift operators, and moving to the left side if you are using the left shift operators. And the bit positions that have been vacated by the left shift operators are filled with 0 if you are using left shift operator, and if you are using right shift operators, whatever the bits are vacated, that are filled by 0. And one example program for the bitwise operators. So this is the header file, and the next one is the main function, and we are using the unsigned int. A is equals to 60. So int is a data type as we know, and coming to the, if you are using an unsigned keyword, unsigned is meant for we are using only a positive numbers. So we are dealing with the bit level operations. So if you are dealing with the bit level operations, obviously the value should be always the positive one. So if you are using the unsigned, so we are telling that it is an only positive, we are using only a positive values. Coming to the signed, if you are using the signed keyword, then we are telling both the positive and the negative values we are using. So here we are using only positive values, so that is the reason why we are using here unsigned data type, unsigned int data type. So we have given the A is equals to A value as 60 and B value as 30. So if we convert that 60 value to a binary, so that binary value will be this one. If we convert that 60 to a binary, so the value will be this one. And if you are converting the 13 value to a binary, so the value will be this one. And if you are converting the 12, so how to convert it into the binary? If we divide by 2, we are taking the result as a remainder. So the remainder we are taking from the top to from bottom to the top. So these conversions you need to learn. So, and here one more operator that we are taking, that is int C is equals to 0, and C is equals to the next operator that we are doing is C is equals to A and B. So here A value is 60 and B value is 30. So these are the two values that we are using in this operation, in which in A and B. C is equals to A and B. This is the operation that we are performing. A is 60 and B is equals to 30. So as we discussed in the previous slide, that if you are using a bitwise AND operator, the two bits should be 1. So then only the resultant bit will be the 1. Otherwise, the resultant bit will be the 0. So here, if we calculate this, see, 1 is 0 and 1. So we'll get the last bit as a 0. And 0 and 0. So obviously it is 0. 1 and 1. So here the two bits are 1 and 1. So the bit we have got here is 1. 1 and 1. So here also the two bits are 1. So we got the bit as 1. 1 and 0, it will be 0. 1 and 0, 0. 0 and 0 will be 0. 0 and 0 will be the 0. So here all the bits we have got it as a 0. So this is the resultant thing that we have got by using this A and B operator, by using this bitwise AND operator. So this value we are converting it into decimal. If we convert it into the decimal, we will get the value as a 12. So the answer is 12. And printf. By using this printf statement, we are writing line 1, value of C is equals to percentile D, and the C value we are printing. After performing this operation, the C value we are printing. So the C value, it is this one, and that one we are converting, that the compiler is converting it into the decimal, and the decimal value we are assigning to this control string piece. So we are performing in the bitwise operators in the bit levels. So whatever the decimal values we are giving to the compiler, that will be converted into the binary form, which is nothing but a bit level, and then the operations are performed. And in the next statement, C is equals to A or B. So these two values, this is A and this is B. So as we discussed about this OR, if any one of the bit is 1, so the resultant bit will get it as 1. So 0 and 1. So here the 0 and 1 we have. So the bit we have got it as 1. And the next is 0 and 0. So the bit we have got it as 0. 1 and 1. So the bit is 1. 1 and 1. The bit is 1. 1, 0 and 1, 0. 1, 0, 1, 0. For these two cases, we'll get the bits as 1 and 1. And the rest two bits are 0, 0. So we'll get the resultant as 0, 0 if you are using this bitwise OR operator. And by using this printf statement, we are printing the C value. So after converting this bit level, after converting this binary number to a decimal number, we'll get a value of a 61. So the 61 value will be printed in the output screen by using this printf statement. And the next C is equals to A or B. So as we discussed about this XOR operator, the two bits should be identical. If the two bits are identical, so then the resultant bit will be equals to 0. So if the two bits are not same, then the resultant bit will be equals to 1. So A is 60 and B is 60. If you are performing this A or B, A value is 60 and B value is 30. So the decimal equivalent of these values are these both, and we are performing this XOR operator. So if the first bit is 0 and the second bit is 1, so the resultant bit will get it here as 1. The first bit is 0 and the second bit is 0, then the resultant bit will get here as 0. First bit is 1 and the second bit is 1, we'll get the resultant as 0. If here we have the two identical bits. So if the two bits are identical, so the resultant will get here as 0. And here also the two bits are identical, so the resultant bit will get here as 0. So if it is 1, 0 and 1, 0, then the resultant bit will be equals to 1 and 1. So the two bits should be different. So if the two bits are different, so then we'll get the resultant value as 1 if you are using this XOR operator. And this is a binary value that we are getting after performing this XOR operator, A XOR B. So that value will be assigned to the C variable. So this binary value is converted into decimal. So that decimal value is nothing but a 49. And by using this printf statement, we are printing the C value. The C value is 49 by using XOR operator. And the next one is C is equals to not A. C is equals to not A. It is a not operator. So not operator is, if it is true, it is converted into false. If it is false, it is converted into true. So thus not operator we can perform only for a single variable. So for A itself, we are performing that not operator. If the bit is 1, it is converted to 1. If the bit is 1, it is converted to 0. And if the bit is 0, it is converted to 1 by using this not A. So see here, we can check here. If the bit is 1, we are getting the, if the bit is 0, we are getting the resultant bit as 1. And if the bit is 0, we are getting it as 1. If the two bits here, the two bits are 1. So the resultant we are getting here it as 0. And the next 1, 1. So the 0 bits, and next 0, 0. So the 1 bit. So that one, if we are converting it into this, so we are getting it as a minus 61 value. So by using this printf statement, we are printing the value and we are getting in the result as a 61. So next, in the next statement, we are performing left shift operator. So we are performing some left shift operator. So this is the A operand, and how many bits we are moving towards the left? 2 bits we are moving towards its left. So this bit we are moving towards its left. So this bit will be the starting bit will be coming here, and the next bit will be coming to the next side, next beyond that, and the next bit will be over here. The next bit will be shifted to here. Next other 2 bits will be shifted to these 2 places. In the leftover space, whatever we have left, whatever those are vacant, that will be filled by using zeros. So why we are moving 2 bits towards its left? Because we have given a left shift operator to specified number of bits is 2. So that is the reason why we are moving the 2 bits towards its left. So after converting this value to the decimal, we will get the 240 as a result. That 240 value will be assigned to the C variable, and by using the printf statement, we are printing that C value after performing the left shift operator. And coming to the right shift operator. So right shift operator means we are moving the bits towards its right. We are moving the bits towards its right. So how many bits? 2 number of bits we are moving towards its right. So what operand we are using here? A. So the value for this 60, we are moving the bits towards its right. So if you are moving 2 bits towards its right, these 2 bits will be missed. We are skipping those 2 bits. So again, this 2 bits the first bit will come in the first place, and the second bit will come in the next, and all this rest of the bits will be coming over here, and the leftover space will be filled with the zeros. If you are using the right shift operator, we are shifting 2 bits towards its right, and the same value, this value, the binary equivalent of this value, decimal equivalent of this value is 15. The 15 value we are assigning to the C, and by using the printf statement, we are printing that 15 value. So these are about bitwise operators: bitwise, AND, OR, XOR, NOT, left shift, and also the right shift. Next is an assignment operators. So assignment operator is basically used for equal and equal to operator. So equals to is an operator that is known as the assignment operator. If you are using A equals to 2, that means the 2 we are assigning to the A value. And if you are using B is equals to A value we are assigning to the B. So A is nothing but the 2 value. So the 2 value we are assigning to the B. For suppose if you are using A is equals to some 5 and B is equals to some 6 and C is equals to D. So we don't have any value of this variable. So in that case, some garbage value will be stored in this C value. So the sum of the assignment operators are equals to, this is the main assignment operator, that is equals to, we are assigning the value to the variable by using this equals to operator. So the next shorthand assignment operators, we are calling it as plus equals to, minus equals to, multiplication equals to, division equals to, modulus equals to, bitwise and equals to, bitwise or equals to, bitwise XOR equals to, left shift equals to, right shift equals to, and lambda operator. So plus, see, this is an addition assignment. So if you are using this operator, x plus equals to 5. So this is almost equivalent to x is equals to x plus 5. So x minus equals to 5. This is almost equivalent to x is equals to x minus 5. Some of the shorthand assignment operators, we can also use this kind of assignment operators in the C programming language. So one of the basic simple assignment operator program. So inside the main function, we are assigning the a value is equals to 21 and we are declaring the c value by using the c is equals to a. We are assigning the a value to the c variable. So that c value will be is equals to 21. And then next, by using printf statement, we are printing it. And next, we are using this plus equals to shorthand assignment operator. So this is almost equivalent to c is equals to c is equals to c plus a. So already we have a value of c here, that is 21. So the 21 plus a value is 21. So 21 plus 21 will be is equals to 42. That 42 value we are assigning to the c variable. So by using printf statement, we are printing the c value. So that value will be is equals to 42. And the next c minus equals to a. So we are subtracting that c. This is almost is equivalent to c is equals to c minus a. So the c values here is after completion of this operation, we have got the c value as 42. So 42 minus 21. So the 21 value is a value is 21. So 42 minus 21 will be 21. So that 21 value we are assigning to this c. So by using this printf statement, we are printing the c value. C value will be is equals to 21. And in the same way, we are applying the same operation, that is c is equals to c into a. In this line, we got the c value as 21. So the c value is 21 and a value is, we have initialized, that is equals to 21. So 21 into 21 will be is equals to 441. So that value will be assigned to the c variable, and by using printf statement, we are printing the value. And that same logic is applied to same operation that we are applying for division equals to, and also same that is applied for c modulus equals to. And next is an conditional operator. The conditional operator is also known as a ternary operator. It is also known as a ternary operator. It is like a decision-making statements which depends upon the expressions. It is nothing but a decision-making statements. So the operator that we are using here is question mark and the next colon. Question mark and the next colon. A conditional operator works on 3 operands. So it is known as a ternary operator. The behavior of a conditional operator is if-else statement. If the decision is true, then the true block will get executed, and if the decision is false, so it will come to the false part. And the syntax for conditional operator is expression 1, question mark, expression 2, colon, and expression 3. So one of the example, that is, this is header files, and inside the main function, we are telling whether the person is eligible to vote or not by using a conditional operator. So int age, by using printf statement, we are asking to enter age, and by using scanf statement, we are reading that age, and this is the condition. So age greater than or equals to 18. As we know, if the person is greater than 18 years, so that person is eligible to vote. So we are writing the condition as age greater than or equals to 18 and the next question mark. This is the operator that we are using for ternary operator. Ternary or conditional operator. If this condition is true, then by using this printf, we are telling that person is eligible to vote, or else this is the true part. After question mark, we are writing the true part, and after colon, we are writing the false part. If the condition is true, so this will happen. If the condition is false, then this will happen. So this is a simple example for a conditional operator, and we can also find the greatest of 2 numbers. The number is even or odd. For the number is even or odd, we are reading the number, and next we are writing n modulus 2 double is equals to a 0. So if this is true, then we are telling printf the number is even. Else we are telling printf the number is odd. So by using ternary operator, we can solve this. Ternary or conditional operator, we can also solve even or odd, and also we can also find the largest and smallest of two numbers by using the conditional operator. And the next is a special operator. Some of the special operators that also are there in the C program. So those are size of operators, and the next one is pointer variable, next comma operator, and the next one is the dot operator. So size of operator, it tells about the size of the memory that was allocated for a variable. So the size of operator is used to find the size of memory in bytes allocated for a variable. So the syntax for this is size of and the next variable name. So some of the example is size of A. The result of A is 2 if A is an integer. So if an A variable is of integer type, then we are telling that the size of that integer data type to occupy the value is 2. So this is one of the example program for a size of operator. So here we are taking int A is equals to 10, float B is equals to 2.5, char C is equals to A, and double D is equals to 12.85. And by using this printf statement, we are printing the size of A. The size of operator, we also can mention the data type. Size of int, that also we can mention. So what is the size of that int? A is of type int. So int has some 2 bytes of, allocate some 2 bytes of memory to store that particular value. If you are using the 16-bit compiler, it allocates 2 bytes, and if you are using 32-bit compiler, it allocates some 4 bytes. So the size of A is 4 bytes. So that 4 bytes will be in place of this control string percentile D. So the value of that size in bytes of that A data type, that A variable in int data type is 4. And the next size of B. B is of float type. For the float also, it has 4 bytes of storage to occupy that particular value, float value. And the next for char, size of C. C is of type character. So it has 1 byte size. And the next size of double, it has 8 bytes. So instead of this variables, we can also give size of int. So what is the size of int? That will be displayed on the console. So this is a program for a size of operator. And the next is a pointer operator. So it is used to define a pointer variable in the C programming language. So we are going to discuss in detail about the pointers concept. And comma operator, it is used for separate variables while they are declared and separate the expressions in function calls and etc. And dot operator, it is used in the to access the members of structure and union. So this one also, the dot operator, we are going to discuss in the structures concept, in detail in the structure concept. And today's class, we have discussed about the operators and also the types of operators. And in the next class, we are going to discuss about expression and the precedence and associativity of an expression. Thank you.